Good evening, everybody, and welcome to another episode of the vBrownBag webinar. Tonight, we are going to be doing a continuation of our Python for DevOps series, talking with Python developers and learning how to level up our skills. I'm extremely excited tonight to present to you Michael Herman. He's actually given me a sneak preview of his deck, so he's going to be doing a presentation about himself. But I've been a longtime fan of his, and he's got some really, really good material out there. And tonight, he's going to be talking about Python and my other favorite topic, AWS. So it's going to be jam-packed with some fun knowledge. But before we get into that, a couple of housekeeping notes. If you want to get in on the conversation, we will be fielding questions from the live Q&A from the live audience, but we will also be monitoring the @vBrownBag and hashtag vBrownBag on Twitter. So I will be, and Joe Hughes, who is also here. Say hi to everybody, Joe.
Heyo.
We're going to be fielding your questions and keeping an eye on the Q&As and watching the tweetosphere and coming up with our own dumb questions for our very, very bright presenter tonight. So with that, we're gonna kick this off. Mr. Herman, are you there, sir?
I am here, yes.
Do you prefer Michael or Mike?
Let's do Michael.
Let's do Michael. All right. So Michael, I'm going to give you the power. You are presenter, sir.
Cool. All right, so can you see my screen?
Yes, sir, I can see your screen.
Awesome. Okay, so yeah, I'm gonna jump right in here in just a second, but yeah, I guess for those that are listening, if you do have questions, please send them Chris's way, and then Chris, if you want to just interject in whenever. So it'll definitely be better with questions throughout rather than afterwards, I think. So
absolutely.
Feel free to ask questions. Cool. Okay, so I'm going to be talking a little bit about AWS Fargate tonight. So in terms of an agenda, I'm going to talk a little bit about myself. I'm going to go over some objectives, so some takeaways that you should be able to take away from this talk. Dive into a little bit of theory, so talk about what EC2 is, what ECS is, and then what ECS on Fargate is. And then we'll be jumping into the practical portion of this. So I'm going to go over the project overview that we're going to be working on, show how to set it up locally, talk about some AWS prerequisites, get into ECR, which is an image registry, and then dive right into ECS Fargate. Okay, so a little bit about myself. So again, my name is Michael Herman. From Denver, Colorado. I'm an engineer, educator, and an entrepreneur. So during the day, I am a full stack engineer at an agency called Eldarian. I also do quite a bit of DevOps for them as well. And then I also run a company called testdriven.io. So I'll just pull that up just really quick. So that's an education platform for, say, mid to senior level developers that are sort of looking to level up their skills on microservices and AWS and whatnot. So if you already know how to build a CRUD app, this would be sort of like the way to level up. Other than that, I'm also an organizer of the Denver Node.js meetup group. I used to be a lead instructor for Galvanize for the full stack JavaScript track. I am the co-founder of Real Python, and I also enjoy, I guess, building financial models while listening to Radiohead. So it's a little bit about myself. So, all right, some objectives. So by the end of this talk or tutorial, you should be able to let me just move the webinar control panel here so I can actually read this. Be able to explain the following AWS services and why you may want to use each of them. So EC2, IAM, ECR, ECS, and Fargate. And then we'll describe the similarities and differences between EC2, ECS, and Fargate. Explain what container orchestration is and why you may want to use an orchestration tool. And then we'll dive in on the practical side of things. We'll spin up a Flask app locally with Docker, utilize the ECR image registry to store our Docker images. So we'll build the Docker images locally and then push them up to the ECR container registry. And then finally, we will work with getting the Flask microservice to run on AWS with ECS and Fargate. Okay, wow. So yeah, we'll be moving kind of quickly, but I did go through this presentation earlier, and it did take me about 40 minutes. So we'll see.
Strap in.
Yeah. So EC2 and ECS. So EC2, so that stands for Elastic Compute Cloud. So that is literally just a virtual machine in the cloud. AWS likes to call them instances, but really it's just a virtual machine. So it's great for running a single app or single Docker service. And so, that could be, Spring Boot application, a Flask application. You could run, Mongo database on there, Redis, Postgres, whatever you really want to do. It's good to stick with a single application, especially as your app starts scaling, you're starting to get more traffic. As soon as you get to a point where you need to start scaling, either vertically or horizontally, you probably want to work with more than one EC2 instance. And so you'll probably want to look at another one of the AWS services. And so in the Docker world, you're going to want to look at a container orchestration tool. So if we jump to the management console here, under services, under compute, you can see EC2. If you're not using Docker and you want to sort of scale out your application across multiple EC2 instances, you'll probably want, or scaling in general, you want to look at probably either Elastic Beanstalk or Lambda. I'm actually not exactly sure what Lightsail is, but the rest of these, or actually ECR, ECS, EKS, are going to be your container type platforms, but I'm not sure what batch is either. I feel like there's like 3 or 4 new services that pop up every single day on this, this management console, so it's kind of hard to keep up to speed with everything. Cool. So going back to the slides here. So again, on the Docker side of things, you want to use a container orchestration tool, and so probably the one that is most familiar to you all is Kubernetes, and that comes from Google. So what is a container orchestration tool? So again, as you move from a single machine to multiple machines, you need some sort of layer there to manage what's happening across your entire cluster or system. So let's say you have, you deployed a Flask application. It's a front-end type application. It's going to be taking in traffic. So let's say you deploy 5 different containers across 5 different EC2 instances. You have a load balancer in front of there. How does the load balancer know, which containers are healthy? Which ones should it route traffic to? If you spin up a new container and it doesn't pass a health check, you shouldn't route traffic to that. So that's exactly where a container orchestration tool comes into play. So Kubernetes is the Google, the big Google container orchestration tool. On the AWS side, ECS is sort of the bread and butter container orchestration tool. And it's really just a way to run and manage your Docker workloads on logical groups of EC2 instances. So ECS is great. I really like it, but it's really complex. There's a lot of different moving pieces here. So this is a pretty typical application, infrastructure that you'd be using with ECS. So on the left-hand side here, I'm not sure if you can see my cursor or not as I scroll over.
Yes, we can see it.
Okay. Is kind of the EC2 side of things. So you have your load balancer, so traffic is going to come in and hit the load balancer, and then the load balancer needs to figure out where to direct traffic to. So let's say in this hypothetical scenario, you have a client application, then you have a users or authentication application. So you have your main route here, and then you have your container here where our client application is running. You map the route to sort of the container using a target group. And then likewise down here, we have a ping and users and auth route that's associated with our users Flask application that's running inside this container. So again, we have the target group down here that maps these together. So then on the right-hand side of things, we have our ECS infrastructure. So we have our cluster, which is a logical grouping of EC2 instances. We have a service. I'll talk a little bit about what that is when we jump into the practical portion of this talk. And then we have our EC2 instances where our containers are running. So obviously a lot of moving pieces there. That's kind of where Fargate comes into play. So Fargate is a container orchestration tool that's used for running Docker-based containers where you don't have to manage the underlying infrastructure. So what that means is you don't have to manage those underlying EC2 instances. So with ECS, you have essentially two launch types. You have with EC2 or with Fargate. So when you compare ECS with Fargate, when you compare that to ECS with EC2, the Fargate flavor is going to be less complex. It's probably going to be more expensive though, since Amazon or Fargate is abstracting out that underlying infrastructure. And you're kind of getting a little bit closer towards a serverless type platform like AWS Lambda or Google Functions or Azure Functions. But you actually don't have to do like a major refactor to your application. So a serverless type platform with Lambda, the abstraction level is at the function level. So you have a Flask app or a Django application, you have to figure out how you can actually break that up into individual functions and how you can trigger those functions. And so there are platforms that help with that. The serverless platform, Zappa, and then Chalice is another one. I think Chalice is actually the official one from AWS, but it does require a pretty big refactor to move a Flask or Django application or whatnot over to AWS Lambda. So Fargate does get you a bit closer without having to actually do a pretty major refactor.
Quick question from the audience.
Sure.
Is Kubernetes so when comparing the container orchestrators, is Kubernetes more a competitor of ECS or is it more a competitor of Fargate? Or is that a valid question?
Yeah, it's definitely a valid question. I would say it's a competitor of both.
Of both, okay.
I think on the GCP side, which is Google Cloud Platform, they have GKE, the Google Kubernetes engine. And someone informed me today that there was something called Google Run, and I haven't looked at it yet. But he wasn't familiar with Fargate, but he made an argument that sounded like Google Run is sort of equivalent to Fargate. So yeah, I would say Kubernetes is probably a little bit more like ECS, and maybe that Google Run, which is a managed platform, is a little bit more similar to Fargate.
Gotcha. Okay, thank you.
So yeah, again, compared to Lambda, you have more control. It's probably going to be a little bit faster, and it'll probably be a little bit cheaper. In terms of performance, with AWS Lambda, you have your cold. So you're basically running functions, and so you have cold functions, you have warm functions, you have hot functions. You get billed when functions are either hot, so they're running, or they're warm. You don't get billed when they're cold, but they take a while to spin up when they are cold. So if you have an application that's taking a lot of traffic, you have to figure out the logic around, okay, yeah, some of this stuff I should probably keep warm. Some of the stuff I could probably spin down and keep cold that doesn't get ran very often, but you have to sort of manage that. That's sort of logic behind there. So you can have some performance hits from that. So I'd say some questions that you'd want to ask in terms of costs. So looking at costs, are you taking the indirect costs like maintenance and upgrades into account? So are you taking into account like having to upgrade the OS or whatever it is inside your EC2 instances? You probably have to spin those down, spin up new ones. And so you'll need to have some sort of DevOps ops person or sysadmin type person doing that. So you're going to definitely have indirect costs there. And then how much you want to think about how much control over the environment do you need, and how much flexibility do you need, and are you willing to take on more of those sort of operational costs, sort of those maintenance costs, to get more flexible environment that you have more control over. So I really like this image here. So this kind of compares the traditional sort of on-prem environments to the different cloud environments, and what you have to manage. So you have to manage everything on the on-prem side. And you can see as we go from on-prem to the software as a service, you have to manage less and less. So IaaS is infrastructure as a service. So that's your EC2 instances, that's DigitalOcean, and then that's also like something like Linode. Your platforms as a service, it's like Heroku, it's Elastic Beanstalk. On the AWS side, that's Google App Engine. On the GCP side, then of course you have the serverless, so that's Lambda, Google Functions, and then you have your software as a service. So ECS and ECS on Fargate lands somewhere in between here. So it's getting you a little bit closer towards that platform as a service. So you're having to manage a little bit less. Cool. Okay, so moving on. So in summary, so some of the main advantage that I would say that you get from Fargate is you could possibly have increased velocity of your team. So since the infrastructure is being managed by someone else, you can really focus on your application, writing that business valuable code, and figuring out how to write the code that you need to differentiate your application from your competitor's application. So focus is solely on your containers or your application. Some of the disadvantages with Fargate, though, is you have decreased transparency, you have less control, it could possibly be more expensive. One that I haven't talked about is vendor lock-in. So the less control you have, the more control that AWS or some other platform is going to have. So you're more tied to that platform, so it's more difficult to move to, say, a different platform or to your own on-prem environment. So I think that's definitely something that you want to think about as you're scaling your application. Cool, so that is all I have for the theory portion. If there are no questions, I'm going to jump into the practical portion of the talk. So I'm going to pause and take a quick drink.
Yep, let me scour the internet while you are drinking. Nothing from the tweets, and Q&A is clear. Nope, we're good to go.
Cool. Okay, so in terms of the practical portion, so the practical portion, we're going to be leveraging ECS Fargate and deploy a Flask application. So basic RESTful API, it's kind of a single CRUD resource for users. So you can get all users, get a single user, add a user, update a user, and I cut off delete a user here just for the sake of room. So your typical CRUD application. It's built with Python and Flask using a Postgres database. Everything is containerized using Docker for WSGI, and then it's being tested with PyTest. And so I do have the code up on this GitLab repo here. And if you are curious about how to build this application, the code is basically the final product from this first course, this test-driven development with Python, Flask, and Docker course. So if you do want to learn how to build the course, you can go through that. But if you do want to figure out how to build that application, there is that course there.
And I will have all of the links that we talk about in the show notes for ease of getting to them afterwards.
Yeah, and on that note, these slides are available online. You can't all here, so hopefully you're not writing down every little thing on the slides. They will be available, yes.
Don't save them from doing all the work, jeez.
Right. Well, I did mention it halfway through, so up to this point. Okay, so to set this up locally, find my terminal here. that something that we all can see?
Yes, that's visible and legible.
So I'm going to push this to the side here. So to set this up locally, you're just going to want to run this docker compose up -d -build command. And what this is going to do is it's going to build the images that come from the docker compose file. And then also it's going to spin up containers. So I'll hop into the code really quick.
Comments from the gallery. Well, I already had a full page written out, so
I'm sorry. You can get
Nope.
your money back.
Don't exactly full refund at the end of the show.
Right. Yeah. So the Docker compose file, this is just a typical compose file that you'll see with the Flask application, but I have two different services here. I have a users application, my users DB application. I'm using just a straight Docker file here. If you hopped into the Docker file, basically downloading or extending from a Python 3.7.4 image, adding some dependencies, setting some environment variables, installing some dependencies, and then copying over the application code. Setting up a volume here, setting up, exposing some ports, setting some environment variables, and then it's dependent on this users DB application, which is the Postgres database. It's a pretty basic Docker compose file there. So build the images and spin up the containers. After that, you'll then want to run these two commands. This will apply the database schema, and this will apply just a basic seed to the database, and then you can run, or you go to this route here, and you can see the two users that are getting sent back, and surprise, surprise, they're both me. And if we also have a ping route here, sort of a sanity check route that just sends back a message upon. There's also some tests in here. So if you want to run PyTest, there's a command for that. Then I have sort of the linting and the whatnot, or the black commands down. The linting, so Flake8, black is a code formatter, and then isort is another sort of linter for dependencies to make sure they're in the right order. So you can run each of these commands here as well. So that's the basic application here. Again, it is just a basic CRUD application, so all these different routes and endpoints do work. Okay, so that's the application. That's how to run it locally. So in terms of AWS, you're going to want to have an AWS account. If you do click on this link, it will take you to the free tier. So if you don't have an account, there is, I guess there's 60 of their products are available. They have like upwards of 300, so you're obviously not getting all the products, but you do have a lot of room to play with here. So if you don't have an AWS account, you do need to sign up for one. Then you can install the AWS CLI. And that is just it's a Python library, so you can just pip install that. And then you'll want to set up an IAM account with the following group level policies. So an IAM is identity and access management, so that's for authentication and authorization. So who are you and what can you do? And so you want to set it up with these two roles so that you have access to the EC2 or the ECR registry, and then you'll also need this the ECS service role here. Okay, so ECR again is Elastic Container Registry, and that's an image registry. So it's similar to Docker Hub. Docker Hub, a lot of people are pushing images up there. Say it's akin to GitHub for your Docker images. I think Docker Hub does have a private repo section, or a place you can put private repos. Most of it is going to be public, so ECR is completely private. So you can push images up there with all of your secrets in them, and hopefully no one will find them. So that's why you want to use probably ECR over Docker Hub. It's also integrated into the AWS ecosystem, and it works directly with ECS. So that's another reason why you'd probably want to use ECR over Docker Hub. So you'll want to start by creating these two repos. So from the AWS console, you'll want to go to the ECR dashboard and create two new image repos. So for time's sake, I have already set those up. So you can see Fargate users and then the Fargate users DB. So from there, you'll want to run this command here, and this will log you into ECR. So that way, the AWS CLI is authenticated against ECR. So if I head back here, run that, it should give me a login succeeded. And then you'll want to tag and push those images up to ECR. So you'll want to, if you're going to be doing this at home, you'll want to replace this AWS account ID with your actual account ID. So I have already built these and pushed these up. So you don't have to sit here and wait for me to do that, but I'll just go ahead and build them again. And then I'll push those up again. So the first time you do this, it'll probably take 2 or 3 minutes to actually push them up just because the caching isn't in place. So now if we hop over to the dashboard, so many tabs open already. We hop over to the dashboard here, you can see this should have been pushed 5:52. I'm not sure what the times actually didn't update on there. Actually, maybe it didn't update it because there were no changes to it, so it's still using the one that I updated, pushed up an hour ago. Yeah, those if I had made a change, it would actually make the change to in the console there and say it was updated. So yeah, you'll want to tag and push those images up to ECR. And so now once they're in ECR, we can take those images and hand them to ECS and say, hey, ECS, run these, do your thing. So with ECS, you're going to want to configure the following pieces. So you have task definitions, and you could think of them as blueprints, and those are going to be similar to your Docker Compose file. You have a cluster, so that's just a group of EC2 instances where the containers run, and services are the instantiated task definitions. So I think it's worth noting that if you're running ECS with EC2, you're going to have the same pieces. So nothing is really going to change too much on the ECS configuration side when you're running Fargate. It's going to be a little bit less configuration in terms of EC2 because you're not going to have to configure EC2 instances because, again, Fargate does that for you. So in terms of your task definitions, let's hop back over to ECS. So you can see the task definition piece here and the cluster piece here, and then obviously ECR, which is what we already looked at. So I'm going to pop this open here. Let me split this on my screen. Okay, so for the task definitions, for the first task definition, I'm going to set up, so we want to create new task definition. Right off the bat, you can see which launch type do you want. So again, it's either going to be EC2 or Fargate. And so as a Fargate talk, we will do Fargate. So you want to give this a name. So naming is hard. So let's do test-driven Fargate TD. TD is for task definition. I'm going to leave everything else for now. I'm going to go ahead and set up 2 gigabytes of memory here and 1 virtual CPU. And so this is talking about a task. It's not talking about a container here. So a task, you can think of a task as multiple containers that share a similar state. So most of the time a task is going to probably just be a single container, but you can run a task with multiple containers if you want to. So maybe you want to have your app and you want to actually run Postgres in a container. You can link those together in a single task so that they will run together, or they will be spun up together, and those are going to be spun up in 2 different containers. So I would say more often than not, there's going to be a one-to-one relationship between a task and a container, but that's not always going to be the case.
And for the task size, when you're allocating memory and CPU to your task, where are those numbers coming from? Is that from experience? Is that from the size of what you're running in the container?
Yeah, that's going to be based on what you're running in the container.
Okay.
So you can see here, you can go, if you're using just one virtual CPU, and to be honest, I don't know what a virtual CPU is. If I had to guess, that's probably similar to a single core, but I don't know if that's technically correct. But yeah, I mean, this is just going to be based on the application that you're running.
Well, you're on the phone with 2 old VMware pros. We can talk about vCPUs until we're blue in the face. But that's.
I guess I'm probably incorrect there, right?
It depends upon the threading. It depends upon the co-stop and co-wait. There's a whole bunch of different variables within a vCPU, but we're not going to get into that at all.
Good. So from there, you want to add your containers. So I'm going to add a quick container here. So you want to give it a name. So let's just do test-driven users. Then you're going to want to grab that image name. So if we head back over to ECR repositories here, I'm going to grab the URI here, pop it in here, and then give it a add the tag on here, and it's going to be the latest tag. That's what I believe I pushed it up as. Let me just double check that. Now, what did I do? I grabbed the DB one here. So just double check that I used the latest tag. So in the Docker world, latest is akin to master on the Git side of things.
Gotcha.
You almost never want to use the latest tag because that's just what it's going to default to. So if you have multiple environments that you're pushing to, you want to sort of like differentiate your tags by maybe like your environments. So instead of staging production, you may want to put in a Git hash there. So that way you can tie your running container back to code in case there's an issue that you need to debug in the container. So this is just a demo, so I am just breaking all the rules and using the latest tag here. Let's see, so got the container name, got the image name, or popped over the image here. And then I'm going to want to expose port 5000 because that's the port that I'm using. It's going to be what the Flask application is running on. So just put port 5000 there. And I'm going to go ahead and add that container. So I could add another container right now. I could add the user's DB container right now and associate it to this task. Just for the sake of time, I'm just going to do the users for the Flask application for now. So I'm going to go ahead and create that. And I'm sorry, the responsiveness of AWS is terrible, but I'll just make this big real quick, and you can see that I do have a new task definition here.
That's okay. So we're all used to that.
So next, I'm going to want to set up a cluster. So again, a cluster is going to be the logical grouping of C2 instances. So you create the cluster. Since I am using Fargate, I'm going to use the networking only template. I'm going to click next there, the cluster name. Let's just do, Fargate, say Fargate demo, and then I'll create that. That is all you need to do for the cluster. And so next, I'm going to want to add a service. So I can create here for the service. Again, you have your different launch types here. You have Fargate or EC2. So I'm going to choose Fargate. This is going to be associated back to a task definition. So this is going to create a new instance of that task definition. I only have one revision right now because I just created it. I'm going to keep most of the defaults here for the service name.
So, quick question on that revision ID. Is that population of latest there in the quotes your tag, or is that actually showing that that's the newest revision that it has?
The latter. So this is just
Okay.
the newest revision that it has. This task definitions are not associated with the image that was the underlying image, but I can see how that would be confusing. But yeah, if I do have more revisions here, then it would just show like 1, 2, 3, and then if 4 is the latest, I'll say 4, and that'll just be the latest.
Got it.
And this is like a new UI thing. I think last year they didn't have the latest one on here, and it would not default to the latest, I feel like, when you would configure it. So you would always have to like go and find the latest one. So that was a nice little UI UX thing that they put through.
Nice.
I'm just going to run one task of this since it's just a demo, and I'm going to keep the deployment type rolling update type here. You can do, there's obviously other types of deployments that you can do. You have blue-green deployments there, but I'm not going to get too far into that. Okay, so next I'm going to want to set up VPC. So I'm just going to use my default VPC for now. I'm going to select just 2 subnets, and let's see, for the security group, I already have an existing security group set up where I think all of the ports are exposed to this. So if you're creating a new security group, you'll definitely want to expose port 80, port 22, probably a couple other ones too, but I'm going to go ahead and just select this existing security group that I've set up. Save that. Next, if this is a production application, you definitely want to add a load balance. So since I'm using Fargate, definitely want to use the application load balancer. And so if you don't use a load balancer, you get a different IP every single time a new task is spun up. And so yeah, if you want to have that static IP, then you're going to want to set up an application load balancer, and that will also allow you to set up health checks. So health checks are, essentially, I had that ping route that all it did was return Pong, and so what a health check will do is it just will periodically ping that basically, and as long as something comes back. In this case, it would be like a 200 response. You can do other sort of health checks there, but I like to just set up just a basic, quick sanity check that, hey, that there's a 200 response. You can do other things. Maybe you hit a database and grab certain stuff out, but you do want to put in some sort of health check so at least the load balancer can test out to make sure that your application in theory works if they start routing traffic to it. So I'm not going to set up a load balancer right now. I'm not going to enable service discovery for now. I'm just going to go right and just set this thing up just to get this running.
So just for coverage sake, there was a question about security groups in the Q&A, but the type of question that it was far beyond the scope of this particular talk. I would encourage people that do have questions about the basics of creating security groups to look at some of our older videos from the learning how to or studying for the AWS Solutions Architect exam, and that covers security groups and the creation of EC2 instances ad nauseum.
Well, I'm glad you didn't filter that or relay that to me then.
Yeah, exactly. No, that would have taken us down a rabbit hole that would have chewed up 10, 15 minutes.
You can see that this is spinning up the task here. Now the task is running. So I'm going to grab, if I go into the task here, I can grab the public IP. And if all worked out, I should be able to go to this ping route. And it's not hitting the ping route. It's not working. Why is that?
Was your outbound port on 5000?
Oh yeah, that's right.
Or maybe 5001?
Spinning. What's going on there? Okay, well, I guess we'll be debugging this live.
All right.
Sweet.
Okay, so let me think on what possibly could be going on here. So I go back to my task definition and make sure everything is set up there correctly. I'm just going to create a new revision of this. Let me just double check the container is set up right. So this is grabbing Fargate users, is grabbing the latest one, 5,000 there. All that should be good.
I'm getting a connection refused. Is it in the right security group? I love troubleshooting.
So you can see here, I guess it does default to whatever it was before, but one is no longer latest because I did create a new revision of that.
Ah,
Nice.
Check and make sure this is in the right security group. Yeah, all traffic is exposed, so it should be good there.
unless somebody immediately compromised it.
I guess this is a live talk though, so yeah.
Yeah, but Graham's not on, so we should be safe. Graham's one of our regulars, a bit of a hacker.
And the other thing I can think of is maybe this task rule here. So let me update the service again. So it's still, you can see the task definitions here. It's still running task 1 here, running 1, 2 here. I'm trying to get it to spin up 3 right now. So should take, oops. I'll just force it to run a new task real quick. Yeah, I think I want to do that. Just wait it. Surprised it's taking that long to spin that up.
So I have a dumb question. When you spin up a container like that, does it? Oh yeah, there it goes. Does it respond to ICMP as well, or is it just going to talk on the ports that you've provisioned in the container?
It should just talk on the ports. Okay. that's not the right IP address anymore. So well, I am not sure what it is. Great.
It worked in dev. Wait a minute. No, sorry.
Yeah, see, templating network only, blah, blah, blah. Yeah, I cannot think of where else this would be doing that. Well, I'm not going to sit here and debug like this for
That's okay. I mean, honestly, live demos, sometimes they go great, sometimes they don't. So that's we didn't sacrifice enough goats to the demo gods today, apparently.
Yeah, as soon as the call is over, I'm going to figure out exactly what it is.
Right, exactly. Yeah, I'll be like, oh, yeah, that's right. That's how that goes. Dadgummit. Well, I mean, if you ever want to do another one of these, we can certainly. So we've actually done that a number of times, where a live demo has gone awry, and then we've done a follow-up episode, either out of band or with another live audience, to cover the troubleshooting pieces of it. So. More than welcome to do something like that if you want to, but I mean, obviously you've got more stuff to well, actually, do you have more stuff to talk about, or no? That's it.
Yeah, I was going to talk about some next steps,
Cool.
but yeah. So the next thing you'd want to do is spin up that containerized Postgres service in the cluster. So to do that, what you would essentially do is go back to your task definition here. You want to create a new revision of it. And then you can spin up a new container here. So same sort of thing. You just call it test-driven-users-db, put in the image there, and do the same sort of port mapping type thing. And then you would also then want to go back to the test-driven users container and then link the two containers together, so that way the test-driven users, the Flask application, can communicate with Postgres. So then what you'd have is you'd have a single task. Inside that task, you'd have two containers running. And so you'd have your Flask application and you have Postgres. Mm-hmm. So after that, you want to configure, probably configure your load balancer and add health checks to the service. So again, something that is going to just make sure, hey, that new container is healthy before it gets put into production. And then I would recommend taking Postgres out of a container and then using RDS, which is Amazon's sort of database as a service, so relational database service that they have Postgres and MariaDB and all that good stuff there. So I don't think it's wise to manage Postgres in a container unless you want to deal with all the backing up and whatnot, and all the fun that you have with managing a database. I would just abstract that out to RDS.
You mean you don't want to put a inherently stateful piece of information into an inherently unstateful container? That's so weird. Why would you not want to do that?
Yeah, putting a stateful application into a container, it's meant to be ephemeral, meant to spin up and down. You definitely have the headaches there. You have to deal with volumes and backing all that up. So definitely something that I do not want to deal with. So again, you can grab the code here. I do have a further step-by-step process that I guess, fingers crossed, actually works in the third, in this AWS Flask React course. So I do go over ECS plus EC2, and then I compare that to Fargate. And yeah, it definitely does work. So
cool.
Unlike this demo.
Very cool.
So contact info there. I got my email, my personal site, mherman.org, and then my Twitter alias handle there.
Yeah, and I definitely do encourage our viewers to follow Mike at Mike Herman at Mike Herman on Twitter. He's always got some good information that he is sending out on the tweetosphere. Cool. All right. So I think we fielded a lot of the questions as we were proceeding. So let me do a quick thing. Mr. Hughes, do you see anything in here?
Nope. I don't see a whole lot coming on.
Nope, there's some people saying thank you and great job and appreciate the info, but no additional questions. So I believe that we are good for the evening.
Awesome. Well, yeah, I appreciate everyone listening. I definitely will spend the next 10, 15 minutes debugging this, and hopefully we'll have an answer to what is going on before the night is through.
Cool. Yeah, and if it's something that, again, if it's something that you want to do a quick record session for later on, we can certainly do that. Or if it's an easy forehead slapping answer, then we can just tack them into the show notes and say this was the fix that Michael found at the end of it. So either which way, whichever you prefer.
Cool. All right.
Excellent. All right. Well, everybody, thank you once again for joining us once again on vBrownBag. Next week, we are going to be continuing our Python series. We are getting towards the end of it, though, so make sure you join us and ask questions and get all of your Python needs done, because we are about to wrap it up, aren't we, Mr. Hughes? It's been a long run, but we're finally running out of things to talk about with Python. All right, everybody have a wonderful evening, and we'll see you again next week.